Welcome to the physics class, BSc, third semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, unit 3rd, Theory of Dielectrics and the Moving Coil Galvanometer. In session 5, we learnt about the contents of electric displacement vector D and electric susceptibility P. Electric susceptibility chi. So first we seen about electric polarization vector P. It is what is meant by definition. So in this case already we knowing about this diagram is familiar. That is an electric dipole. Electric dipole is the system of the particles which is two equal and opposite charges separated by a small distance d. It is known as an dielectric dipole, which is formed after the application of the electric field in case of the dielectrics. What happened? Now we seen when dielectric is placed in an electric field, its molecule becomes an electric dipoles. Its molecules becomes what? Electric dipole, and this dielectric is said to be an electrically polarized. This dielectric is said to be an electrically polarized. It means dielectric material, it will be placed in the two parallel plates of the capacitor. One plate has a positive charge and another plate has a negative charges. In this direction, in between these two plates, dielectric will be acts as a medium. So in this case, applied the electric field in the direction of plus charge to the minus charge, and the electric field will be after the application of the electric field, dipoles will be formed. Dipoles will be formed means the positive charge of the atoms will be moving in the direction of electric field, and negative charges will be pulled in the direction of the opposite to the electric field. Opposite to the electric field, these dipole moment, this distance between positive and the negative charges, it will be forms as an dipole. After the formation of the dipole, polarization will be takes place. This polarized vector produces an electric field EP. It always produced in the direction of opposite to the applied electric field. This is the direction of polarized vector. This is the direction of applied electric field. So, in the dielectrics having in case of a solid material, the periodical arrangement of the atoms in the 3 dimension will be takes place. That's why all the atoms in the presence of dielectrics, they are forms as a dipole moments, or it forms as a polarization. This state of polarization described by an polarization vector, which is defined as an dipole moment per unit volume of the dielectric material. This polarization vector is related to the bounded charges. This polarization vector is related to what? Bounded charges. Or polarization vector, it's also defined as an induced surface charge per unit area, that is surface density of the bounded charges in dielectric material. This diagram is shows the dielectrics, what happens in the presence of electric field between the two parallel plates of the capacitor. Dipole moment will be formed and also takes place as an polarization will be obtained. Now we are seeing the electrical induced dipole moment of the dielectric. Induced dipole moment of the dielectric, here it is represented by n small p I. I, it is represented as an induced, means applied after the application of the electric field, dipole moment will be formed. Now we see the volume of the dielectric material is capital V. In certain textbooks, induced dipole moment is represented by mu. In certain textbooks, mu is represented by an induced dipole moment. So now we seen that we know that in polarization vector, it is defined as the ratio of dipole moment per unit volume. Therefore, capital P is equals to Pi dividing by capital V. So, Pi is an induced dipole moment. It gives the representation of, it is the product of charge and the distance or thickness of the dielectric slab, or thickness of what and dielectric slab. So, next, the direction of the P vector or polarization vector, it is represented in the opposite direction, that is minus Q to plus Q. So, here in case of polarized electric field will be applied in the direction, this one forward direction. So, means electric field is always directed from plus Q to minus Q. After the formation of the dipole, a polarization will be always takes place in the direction of minus Q to plus Q. Minus Q to plus Q. That's why the direction of the polarization vector is always opposite to the electric field. The magnitude of the polarization vector, it is represented by capital P is equals to Qi into D dividing by V. So, next one. So, volume term, it is defined as an area into displacement or distance, thickness of the slab. So, V is equals to A into D, where A is the surface area of the dielectric material. So, now becomes in capital P, direction of the polarization vector becomes Qi into D dividing by A into D. Volume will be changes. Here D and D, which it will cancels. We getting polarization vector P is equals to Qi dividing by A, means induced dipole moment per charge, induced charge dividing by area. Charge by area is called as an sigma P, that is an surface charge density. Sigma P is the surface charge density. Hence, the polarization is polarization of a dielectrical material P is numerically equals to the surface charge density of the bounded charge. Surface charge density of the bounded charge. We know that Qi is a charge. It has an unit coulomb and area having an unit meter square. It is represented by meter square. Therefore, the polarization vector P having an SI unit of coulomb per meter square. Coulomb per meter square. Next, with polarization vector, finally it is represented by sigma P AL dividing by A cos theta L. This is the general formula. So, in this case, AL and AL will be numerator and denominator will cancel out each other. We will get the sigma P or surface charge density, which is equals to P into cos theta. P into cos theta. The cos theta, which is represented as an unit vector P dot N. So, N is an unit vector which is always the direction surface of the dielectric material which perpendicular to the material, or unit vector normal to the surface. Sigma P is surface charge density due to the induced charges. Next we seen about electrical susceptibility. It is represented by a Greek letter chi. It is represented by a Greek letter chi. So, the polarized electrical susceptibility of the material is obtained when the polarization of the dielectric is caused by the electric field. Polarization will be takes place in case of the dielectric by after the application of electric field. So, the polarization should be directly proportional to the net electric field inside of the dielectric. Net electric field inside of the dielectric. Therefore, polarization vector is directly proportional to the resultant electric field. Resultant electric field. So, the proportionality term will be removed by Adding the constant terms, P is equals to epsilon naught, P is equals to epsilon naught chi of E into resultant electric field. Here epsilon naught is the permittivity of air or the vacuum, chi E is the electric susceptibility or proportionality constant term. It is known as an electric susceptibility. Hence the susceptibility for a vacuum is 0. Susceptibility of a vacuum, there is no takes place of polarization. That's why susceptibility in case of vacuum is 0. Chi as susceptibility has no units. There is no SI unit. It has a constant value. So therefore the resultant electric field E will be obtained as the differences between applied external electric field E naught minus polarized electric field will be obtained due to the polarization. Electric field will be obtained due to the polarization. We will get the net polarization E. Therefore, P is equals to epsilon naught into chi E into E. So, we want chi E means susceptibility of the electric vector. Susceptibility of the electric vector. Rearrange this equation. We will get chi E is equals to P dividing by epsilon naught into E. P dividing by epsilon naught into E. This is the electrical susceptibility. Electrical susceptibility. So now we see the electrical displacement vector capital D. Electrical displacement of a vector is the charge per unit area. Charge per unit area. Charge per unit area is displaced across a layer of the material in dielectric substance when it placed across a electric field. When it placed across a electric field. It means an dielectric material, it will be placed into the in between the parallel plate. The number of charges per unit area, we call it as an electrical displacement vector. In simple words, it's measured charge per unit area. Charge per unit area on the surface of the conductor. Therefore, electrical displacement vector D, it is given by generally D is equals to epsilon into capital E. Epsilon into capital E. Epsilon is the product of epsilon naught into epsilon R. Here epsilon naught is the permittivity in free space, and epsilon R is the relative permittivity of the material. Relative permittivity of the material. This is the electrical displacement vector. Therefore, D becomes epsilon naught into epsilon R into E. Epsilon naught into epsilon R into E. Next, in 2 marks they are asking the relationship between D and P. Electrical displacement vector and electrical polarization vector relationship is generally called as an D is equals to epsilon naught into E plus P. Already we know that D is the epsilon naught into epsilon R into E. Substitute these values in the above equation. We will rearrange this. P becomes epsilon naught into epsilon naught will be get common. From this term we will get epsilon R minus 1 into E. So this term will be takes place into the left side. P becomes n. This relationship. This is the relationship between D and P. In this class we have to study about electric polarization vector means what, and it is represented by what term, and electrical susceptibility, and also electrical displacement vector, and what is the relationship between displacement vector and the polarization vector. Thank you for watching.